Hi, I'm Dan O'Brien. I'm the director of the Texas School Project and our UT Dallas Education Research Center. We're a little group of people who works over in the West Tech building, and we're focused on gathering data together for Texas education and other Texas Workforce Commission, other places, so that substantive research can be done in education here in Texas that informs not only Texas, but hopefully the whole country. We have, as part of that activity, we sponsor a seminar series and have monthly or sometimes twice a month seminars and invite distinguished scholars to come and talk to you about education issues. And so I welcome you today, and I'm glad you're here. You know, the Friday before a long weekend, I thought maybe no one would show up. So I'm really proud of you. It must be the new dean has instilled some discipline in this school that wasn't, well, never mind. Anyway, I'm happy that you're here. And our speaker today, Kristen Klopfenstein, runs our seminar series and invites speakers. And our speaker today, Luke, comes to us from the Urban Institute. He is part of a larger project that we're involved in called Calder, the Center for the Analysis of Longitudinal Data in Education Research. You don't have to remember that, but we were an original Calder partner, and we're one of several states working in that environment. I noticed, though, that on Luke's CV, he has worked with Susanna Loeb at Stanford, and I know Susanna, and she's one of the principals at Calder as well. And you have to be really easy on Luke today, because I've worked with Susanna, and she is driven to understand educational issues and how they work. And so she not only is an expert in econometrics and economics of education, but she gets down there in the trenches and actually finds out what's happening in New York, in schools from New York to California, literally. So anyway, Luke has had that experience, and so I'm happy that he'll be here to share some of those experiences with us today.
So, as Dan said, I'm Kristen Klopfenstein, and I'm a senior researcher with the Texas Schools Project and the coordinator of the seminar series. So thank you all for coming. Really, this is a great turnout, especially for our first seminar. I appreciate it. Be looking for the full schedule is actually posted on our website. So feel free to take a look. We've got some really good people coming this year. So I can't add a whole lot to what Dan said, but I just want to point out that what Luke is going to be talking about today in North Carolina is very similar to what the Texas High School Project does in Texas. So I'm involved with SRI International in an evaluation of the Texas High School Project, and when Luke and I started talking about what he was doing in the evaluation of North Carolina, we had instant connections because the similarities are just amazing. So if you are familiar with the Texas High School Project or have affiliations with it, I hope that I'm really glad you're here, and please feel free to ask questions, because a lot of this pertains just as much to Texas schools as it does to the North Carolina schools. So without much further ado, Luke Miller.
So the work I'm going to be presenting today is we're looking, myself and a team of fantastic RAs, which deserve a lot of credit for both patience, as Kristen can attest to yesterday. There was a lot of emails going back and forth between getting graphs to look the way I wanted them to look. So the work I'm presenting today is part of a long-term study that we're doing. We're evaluating the effects of these 3 high school reform models that are pretty common in North Carolina on their effects on moving students through math and science pipelines in high school. So just an outline. I figured I tend not to like outlines, but I figured the talk was going to be longer than a normal talk I give. That might be helpful to keep us see where we're going. So I'll give a bit of a background about the initiative, the policy context in North Carolina, and then how our study is coming in and the various components of our study to sort of assess the impacts of this initiative in North Carolina. I'll move into some of the heavy stuff, the methodology, the data and the sample that we're using, and how we're defining our outcome, this idea of students moving through course pipelines in high school. And then I'll walk you through some of the results that we have before us now. We have results that are looking at the effects on sort of on the average student, and then we're also moving into student subgroup models, where the idea, one of the driving forces behind this initiative in North Carolina is really to target some underserved student populations. So the idea here is to see, okay, do we see differential impacts of this reform on, say, students who have parents who are highly educated versus students who have parents who are high school dropouts. And then I'll walk us through some next steps as we're moving towards wrapping our project up. So the project was motivated by an initiative that was kicked off in North Carolina in 2003. They, with the help of the Gates Foundation, created this organization called the North Carolina New Schools Project, with the mission of creating over 100 new and redesigned high schools. The initiative related to this is in 2006, they created the Turnaround Initiative, which targets the sort of long-term underperforming schools and say, okay, you need to come up with a plan to turn yourself around, and they give maybe 2 years to try that plan out. And if they are still underperforming based on student performance on state end-of-course exams, the school has to implement one of these reform models. The Redesigned High School being one of the 3 that we are looking at in our project. And the New Schools Project helps the schools that choose this model. And again, the real drives behind this initiative is to increase student course taking in college preparatory courses, increase the number of students going into college, reduce the need that those students have for remediation courses, and again, with a big ultimate goal of really developing an educated workforce for North Carolina's knowledge-based economy. So with this study, we're really focusing on this first driving goal behind the initiative. As I said, we're looking at 3 reform models. Those are the redesigned high schools and the early college high schools. Both of these reform models are supported through this state initiative. The state provides some funding for these schools to help them implement this, and that New Schools Project works with these schools to help them implement these reforms. Then we also brought in a focus on another model called High Schools That Work. Schools that have chosen to implement this model have chosen so on their own without marketed state support, and whereas these schools are supported by that New Schools Project. Here, I've left out a letter there, the Southern Regional Education Board. Our contribution to sort of this literature on high school reform is that we're bringing to bear the power of these state longitudinal data sets. So our study has 3 components: the impact analysis, which is the analysis of these data, which is what I'll be presenting today. We also, to get inside the black box, because while these data are still very detailed and give us a lot of power, there's still a lot of uncertainty that we have about when a school says they're doing this thing, what actually is that thing as they see it. And I'll never forget going into a school in Newark, New Jersey, and having the principal tell me, the state required all these middle schools in Newark's public schools to select a model. And she told me that they selected America's Choice because the teachers felt it required the least amount of change, totally undermining the whole idea behind that. So we have this. So we've fielded a study, or a survey rather, of school policies, programs, and practices that the literature and theory suggests can help get more students to take college preparatory classes, do well in them, and go on into college. And so we've collected this information. We will be doing correlational analysis to see how the presence of these types of policies are related to the outcomes that I'm measuring here today. And then we're also this fall will be going into site visits to speak more with faculty and administrators, really trying to get more insight into what is actually going on in these schools. Okay, so let me give you a sort of for those of you who don't know, some background on these specific 3 models. before moving into our actual research design. So I'll start with the high schools that work. This model's been around since the late 80s. Again, it was sort of created and supported by the Southern Regional Education Board. There are currently about 1,200 of these high schools that work, high schools around the country. They emphasize high expectations, rigorous curriculum, extra student support services, and they have sort of special academies for 9th graders as they transfer from 8th grade into high school, and then again focusing on the transition from high school to college. The evidence of that, I mean, if you go to their website, which should be the best available evidence of the effects of this, it's pretty, in my mind, pretty weak. A lot of it saying, okay, schools that schools whose implementation has been better aligned to what our design, the pure design of this model, the outcomes there are better than in schools that have done a less rigorous job of really implementing the key design elements. Methodological preview for how we're going to measure the effects of this model on student outcomes. We've done school level matching. Each school is matched to 3 comparison schools, and we do a difference in difference analysis approach to this. I'll have more information on this as I go through. If you have questions as I go through, please feel free to ask. And if I am going to get to that in 3 slides from now, I'll feel free to tell you to wait. So the second one is the Redesigned High Schools. Again, this is supported by this New Schools project. The idea here is you take a large comprehensive high school and you spin off at least one, if not more, small theme-based schools, small being no more than 400 students. A lot of some common themes in North Carolina are the life sciences, math and STEM, and there's several communication themed schools. The schools tend to be, the themes of the schools tend to be related to the industries near where the school is located. Now, one of the interesting things about analyzing this model is there's really you can think of it as being at least two types of treatments. Now, this comprehensive school implemented the reform because the school's outcomes weren't up to where folks felt they needed to be. So to help that, the school implements this model. But the treatment that the students who then select into the small school, the treatment that they receive is going to be different than the treatment that the students who choose to remain at the large school get. Or if the school fully devolves in, say, 3 or 4 small schools, they have different themes, there's different elective courses, so there could be differences in treatment across those schools. So this is something, a little complication to our analysis, which we have addressed through propensity score reweighting, and we are actually measuring different effects for the large versus the small school. The small schools also get support from the New Schools project, whereas the large school doesn't get it because they're not doing the reform. It's the small school that is viewed by the New Schools project as the reform site. There are some, so this is it was an analysis done of a major initiative, again by the Gates Foundation, that found some evidence of positive effects compared to students in non-reforming schools in the same district. Some evidence around attendance and some achievement and some retention outcomes. Here, again, we do the school level matching. We do this propensity score weighting, which I'll get into, to equate the student samples between the different school sites at different schools at a redesigned school site. And again, we do the difference in difference. The early college high schools. These are brand new schools that a district creates. This initiative is currently being overseen by the Jobs for the Future. In North Carolina, again, this is supported by the New Schools project. There are more than 200 of these early college high schools around the country currently. When a district chooses to create one of these, they partner with a local university. In North Carolina, that's almost always a community college, because the most defining characteristic of the early college high schools is that by the end of 4 or 5 years, the students will, in addition to getting their high school diploma, also get 2 years of college credit. Either they have an associate's degree or they have 2 years of credit that they can transfer towards a 4-year degree. And again, there's some, I would say, moderately rigorous evidence of positive effects of this reform model. I forgot to mention my colleague, another colleague on this project is Julie Edmonds at the SERV Center at University of North Carolina at Greensboro. She has another study that she's working on with folks from APT and RTI, I believe, where what they're doing around an evaluation of this model, there's a handful of schools down there that are oversubscribed. And so they're comparing lottery winners to lottery users, lottery winners versus lottery losers to get at a quasi-experimental or experimental randomized design estimate. And they're also finding some positive effects, at least at the on ninth grade outcomes. Here, because here we do student level matching, and we analyze this through survival analysis. We can't do difference in difference here because these schools didn't exist prior to the reform. So that's going to be a little bit of a complication when I get to my results, and there's a natural tendency to draw comparisons across the three to see which one has the biggest effect, biggest impact on student outcomes. So with the data and samples, again, we're using the longitudinal data from North Carolina. We're focusing on the years 1997 to 2009. Whenever I use a school year, or whenever I use a year, I'm referring to the spring of the year. So this is 96, 97 to 2008, 2009. With this data, we observe student course-taking behaviors as well as their performance on a course-specific end-of-course exam. We also observe their 8th grade test scores, whether or not they took Algebra 1 in the 8th grade. We observe we use these two variables to get a sort of motivation. So how much time in a typical week the student spent on homework. This is from the 8th grade year, as well as their 8th grade teacher's judgment of that student's reading ability. Other characteristics, sort of the standard set, race and ethnicity, parental education, gender, whether or not the student is overage when they enroll in the 9th grade, sort of indicator of whether or not they had been previously retained in grade. And we also have free and reduced price lunch status and LEP status. I don't really use much. LEP status comes into some of our matching, but I don't use it in our models because it bounces around from year to year. And I'm concerned that there was differences in the way that students were classified as LEP. So our outcome. So we have we specify two pipelines. Each pipeline consists of 3 classes. And so progression through the pipeline, successful progression through the pipeline implies that students are taking specific classes at specific time points during high school and performing at a certain level on the exams. So in math, our math pipeline consists of Algebra 1, Geometry, and Algebra 2. We see down here the way that those courses align to the timing aspect of the pipeline progression is that by the end, a student is on track at the end of 9th grade if they have taken at least one of those subjects. End of 10th grade, they're on track if they've taken at least 2. End of 11th grade, they're on track if they've taken at least 3, which frees up the 12th grade year to take, like say, pre-calculus, or a class that has Algebra 2 as a prerequisite. The reason why that course isn't part of our pipeline is there's no state-level tests for those courses, whereas there are for these 3. And these are aligned to the state graduation requirements. Students who are going to graduate with the college preparatory high school diploma must take these 3 courses plus a course with Algebra 2 as a prerequisite. If they take just these 3, then that qualifies them for, I think that's called the College Tech Prep diploma. In science, the 3 courses are biology and then any 2 of 3 physical science courses. So those physical science courses are chemistry, physics, or what's called a physical science here, which I think in Texas is called the ICP. So it's a mixture where you sort of do a semester of chemistry and a semester of physics. And here, the graduation requirements for science are that the student has to take biology, one of these physical science classes, and then an earth environmental science course, for which there's no exam. So what we've done is we've pushed out our time indicators on this pipeline to allow the student to take that required earth and environmental science course at any point during their career in high school and still be on track. So for instance, if they took biology in 9th grade, by the time we see them in 10th grade, they're on track because they're coming at the beginning of 10th grade, they've already taken a course. If they take that Earth Environmental Science here in 10th grade, that's fine. They're still on track because, again, of that 9th grade course taking. And then if they take, say, chemistry in 11th grade and physics in 12th grade, then we would have observed them successfully passing through the pipeline. We have two measures of pipeline progression. One, the main one is persistence, which says not only are they taking the courses, but they're also demonstrating mastery in the subject. Mastery being that their test score on the end of course exam places them in proficiency level 3 or 4. Course taking is just, okay, they've taken the class and we're not so concerned about how they're performing. Persistence is not conditional on taking, so it's not that this is measuring pass rates. So that's just something to keep in mind as we move through when we get into the results. So how does this outcome look at the state level over time? So this is showing you the math pipeline progression rates. The solid lines are the course taking measure of pipeline progression, and the dotted lines are the persistence, which again is not only are they taking it, but they're also demonstrating mastery in the subject. And then you see for each of the different grade levels. So if we look at the triangles here, which is our final measure of pipeline progression in math, which is 11th grade, over time we've seen it's increased from what we've got about 50% of 11th graders in 2001 having taken all 3 classes by the end of 11th grade, increasing to I think it's 63% of 11th graders in 2008. Yet when we also require them to have demonstrated mastery in all of these subjects, we also see an increase here. But we're going from about 31% to about 39%. See this drop here? This is the decrease in the percent of 9th graders who, at the end of 9th grade, have both taken and passed, demonstrated mastery on at least one subject. A new test was introduced this year. There was another test introduced, I think, in 2003. And you don't see a nasty kink where you do here. The difference. But by the fact that we're comparing it to we're comparing the outcomes of the students receiving a treatment to students who don't, we're arguing that this isn't going to cause a major problem in our estimate of the effect, assuming that the new test had the same impact on students at the treatment schools as the comparison schools. For science, we can see a very different picture, where in math, our pipeline progression measures are showing improvement. Science is the exact opposite. What's going on here? And so here, so this is essentially the 9th grade numbers, which is the squares. That's essentially measuring biology. All students are taking biology early on, either in 9th or 10th grade. And so in terms of course taking, I mean, we're up, hovering around 90%. The challenge is, and then they're taking one of the physical science classes, because again, that's what's required for them to graduate. So that's why which brings us down here to the 11th grade numbers. Again, 10th grade course taking, 11th grade course taking, and way down here to the 12th grade course taking. And you see the same drop off when we're looking at our persistence measure. What's going on here is that the state, our science pipeline is essentially expecting the students to go beyond the state requirements, right? The state requirements for graduation is that they take biology, physical science, this is these 2 courses, and then that they also take a second physical science class, in addition to the required physical. So we're essentially requiring them to take 4 classes, where the state says you got to take 3. So that's one reason why why our indicators are lower for science than for math, because we're really expecting more of the students with science relative to what the state requires them versus in math. In math, our courses align exactly to the graduation requirements. Science, they go beyond. The other thing is this big drop off here. In 2003, or 2004 rather, they changed the graduation requirements in science. where they sort of de-emphasize chemistry and physics and emphasize this earth and environmental science. And so you actually see some fairly marketed change in the timing of when students take these classes over time. So if you look at when students take the math classes, they tend to be taking them earlier in high school, towards the end of our observation period than they did at the beginning. And in science, these courses are taking later, if at all. So the number of students who are taking physics or chemistry as standalone classes really drops off quite markedly after the graduation requirements, which sort of makes sense because they're reacting exactly to those requirements. Mm-hmm.
Are these data reflecting the whole state?
Yes, this is entire state.
Except, so are early colleges in here?
Yes.
So they're, if they are a new school, they're just plugged in when they, is it all?
Yeah, so this is student level outcomes. This is percent of students who are doing this versus an average of school level.
Thank you.
Mm-hmm. Okay, so for our sample, we have 64 reform schools across the three types of models, or 64 reform sites, and then we have 93 schools. So we have 18 high schools that work. We have 13 redesigned school sites that then, after they created these small schools, resulted in a total of 29 schools. And we have 33 early college high schools. One thing to note here, which will be another sort of complication to our desire to compare the impacts across these three models, is that there's a definite time preference for when these models were implemented. The high schools that work are early in our time frame, whereas the redesigns in our early college high schools are later. And so when we're looking at a measure, the effect of a specific model, we're comparing it to other students, so we think we're differencing out those time effects. But if those time effects are not constant over time, I'm nervous that comparing our impacts across models are, I'm hesitant to do it, even though it's kind of one of the reasons behind our study. So what's our student sample? So we are following 11 cohorts of ninth graders through high school. So what this is showing you is those ninth graders, the ninth grade cohort in 1998 through the cohort of ninth graders in 2008. We're following them over time. Currently, the 2009 data just became available, and so we're in the process of incorporating that into our analysis. So the results I'm showing you today are from the 1998 cohort through the 2008 cohort. How a cohort is assigned to the treatment or non-treatment depends on when the reform model is implemented at the school that the student is either attending or that the match school is compared to. So take the schools that were formed in 2002. These are all going to be early college, are all going to be high schools that work. The 2002 cohort of ninth graders is our first cohort that's getting the full treatment, and everyone after them gets the full treatment. These three cohorts three cohorts whose high school career crosses over between the pre-reform period and the post-reform period, depending on what grade you are looking at, they are either a pre-reform case or they're getting the partial treatment. So for instance, let's look at the 2000 cohort. At 9th grade and 10th grade, their outcomes are a pre-reform outcome, yet at the 11th grade, they're a partial treatment outcome. Why do I mean partial? Because the model, the reform model, can only have an impact on their progression status at 11th grade if they started 11th grade on track. Because once you fall off track in our indicator, you're off track. So there's only, whatever percentage of kids enter 11th grade on track in that cohort, that's the only group that we can measure this treatment of the reform on. So what we do, and I'll get to this later, we measure both a full treatment and a post-treatment, or a full treatment and a partial treatment. Now, the other thing I showed you before, how the redesigned schools and the early college high schools are implemented later versus the high schools that work implemented earlier. This causes an issue because we have a defined window, an observation window. So 2007 is our last year of implementation of the schools in our sample. We see that we have one cohort, the 2007 cohort of 9th graders. We will eventually, once we finish bringing in this new data, see their full progression through the math pipeline, which goes from 9th to 11th grade. Yet we don't see any cohort getting the full treatment going all the way through the 12th grade, which is our science. So that's another little wrinkle. Okay, so I think I've set up big picture what our issues are, what our sample is. Let me give you some characteristics about the students and schools in our sample. So the majority of these schools are located in rural communities. 72% of the high schools that work, 62% of the redesigns, and 52% of the early college high schools are in rural. Statewide, 54% of schools are rural. If you look at principal turnover at these schools during the 2 years prior to the reform, now I can only do this for the high schools that work and the redesigns because the early college high schools don't exist prior to the reform. The 50% of the high schools that work had a new principal at some point during those previous 2 years. 33% of the redesigned schools had a new principal at some point during those 2 years. Look at, again, that 2-year window prior to the reform. 20% of the teachers at the redesigned schools were new to that school at some point during that 2-year period versus 16% at the high schools that work. And these are higher than the state averages, which are not in my head at the moment. When we shift down to the student characteristics, the early college high schools the students there tend to have characteristics that are positively associated with our on-track indicator, and that they have the highest 8th grade test scores in both math and reading. They have the lowest rates of retention at some point prior to high school, and the highest percent female. The redesigned schools have the characteristics that are least associated with being on track. They have the lowest test scores, prior test scores, the highest rates of being eligible for free reduced price lunch, the highest percent minority, and the highest retention rates. The high schools that work sort of fall in between here. This is going to be the strength of our estimates around the effect of the early college high school is going to be our ability to match students that account for the motivation that's obviously, in my mind, obviously driving the fact that they have the highest characteristics that are positively related to the outcomes. Yes?
Could you speak briefly about the process by which high schools were entered into these 3 programs and perhaps by how students are in the programs? Mm-hmm. That's different from just being at that high school.
Mm-hmm. So for the redesigned schools and the early college high schools in our sample, the state made grants to schools and to districts to create these schools. So there was a competition for that. There were eligibility requirements, and then they selected from that group. The high schools that work schools, as far as I know, they chose that there was some pressure put on them either locally or from the state, but they chose to go off and partner with the Southern Regional Education Board to implement this model. Students. So we believe that the implementation of the high schools that work in the redesign model did not have an impact on the students who were assigned to go to that school site. Theoretically could have if the implementation of one of these models changed the community viewpoints around the strengths or weaknesses of that school, and that caused people to move the residents so their student would be in a different school's attendance zone. Now, at the redesigned school, there is that once they create these new small schools, students select into one of those small schools. And when we look at the characteristics across these small schools, we see that students who select into the health and life sciences tend to have the characteristics that are most associated with on-track performance, where students who select into, say, engineering and applied trades, they have the the characteristics that are least associated. Which is why our attempt to use, our approach of using propensity score weighting within these redesigned schools is an attempt to equate those student characteristics across the sub-schools at a redesigned school site. High schools that were, the third one, the early college high schools, that's a district-wide, essentially it's a district-wide magnet school, where any student from the district can apply to attend this school. And so here, that's why we're matching these students to other students at other high schools in the same district, because they also had the option to, yes?
To clarify, the early college high schools they have to have an academic criteria, is my understanding, like magnet schools you do, and early college high schools you don't.
Yes, and that's, yes.
Magnet is not.
Oh, sorry.
So you can't use magnet for early college high schools. Magnet implies that there's an academic criteria in early college high school you're not allowed to have magnet.
So they don't, they do, there is a selection process. Is there a cutoff point? You're probably, yeah, you're right. So I can't use the term. Okay, but the students do have to fill out an application, and there is some selection across student applicants of who comes into the school. Yes?
Say you're comparing with other high schools in the district, but if most of these high schools are rural, at least in Texas, they don't have more than one.
So they're county level districts, and so there are other high schools we can match them to. But you do raise a point that when you look at the balance of our match, it's best in cases, it's weakest in cases where there's just one other school where we can pull matched kids from. The other thing that buys us some strength there is that some of these early college high schools serve more than one district. So there's one that actually pulls from 3 counties. There's another one that, so in North Carolina, most of the districts are counties. Say 100% of them are counties. And there's 15, I think, that are city schools. And so some of these early college high schools will serve both the students who attend the county schools plus the city schools that are within that county. So we get some more, we can increase our pool of potential comparison students that way. Okay, so where we live or die, our identification strategy. So again, where matching is we're doing for the early college, sorry, I'm getting my schools all mixed up. The high schools that work and the redesigns, we are both comparing outcomes over time plus to comparison over time at students in schools that are not implementing this model. So our approach to identifying these matched schools is an iterative Mahalanobis' distance approach modeled after Rubin and Thomas, where you select a set of key, say 5 key characteristics, identify your matches that way, and then assess the balance on a fuller set. And then you pick 10, and then do that again, and then you can add new ones to it, and then you're sort of constantly tweaking the set, you're tweaking the matches that you're pulling to get the better balance. Most of the schools that are selected are based on between 5 and 8 characteristics, covariates that are actually used in the selection process, but then again, we assess the balance on a whole set of other things. And we bring previous school level percentages of students on track as part of that matching process. For the student level, again, this is for the early college high schools. We use propensity score matching techniques to match students who select into the early college high schools to students in the same district who had the option but chose not to. Here, again, we have a whole host of things that give us a lot of power, but then we also bring in these 2 sort of motivational strength issues, strength characteristics. Again, the amount of time that the student spent doing homework in the 8th grade, and the 8th grade teacher's judgment of the student's reading ability.
Where do those variables come from?
These variables? From the test files.
They're asked before they take the test.
I believe, yep. they're in that file. So yes.
Nice.
Mm-hmm.
So wait, but the teacher judgment.
Oh, so yeah, the teacher. It's also that must be asked at the point of the test.
So the teacher fills it in on the kids.
Yep, these are the kids who are taking. Mm-hmm.
So the kids tell the truth on how much homework they do?
So okay, so yes, yeah. I mean, so yes, and you know the same thing with the teacher judgment. The kid might be a great reader, but the teacher just can't stand the kid, or the other way. Like this kid really tries really hard, and he does well, but if you look at the test score. And you want to believe the test score. So you got all those measurements, yeah, la 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 la. So they're used here to match. They're not used in our models. So here, this is done, again, again, thank goodness I have good RAs because they're very patient. I'm always asking for one more thing. So here, this is all done, all this matching is done within a school, so which is a county. So we had a whole bunch of different specifications of our selection logistic model that were used to predict the propensity score. Again, we're doing that, identifying matches a whole bunch of different ways, different numbers, 1, 5, 10, with, without matching, with, without calipers, and always assessing the resulting balance that we get from all of these things. The spreadsheet goes on and on and on. The end result is that we ended up picking the 10 nearest neighbors for each nearest neighbor matches for each of these students, again from in the same district. In 26 of the 33 early college high school sites, the best match was with replacement, which those smaller districts, they're obviously going to be in this group, where the larger districts, we can get a better match with selecting these without replacement. We looked at the calipers. If you put a caliper of 0.01 on it, on the propensity score, so that's 1% difference, 85% of our matches are within that caliper. And the resulting balance, I didn't feel justified the loss of our 10 nearest neighbor. I wanted this 10-to-1 ratio. That's why we ended up there. That took a long time. Okay, so my impact results are going to live or die by whether or not people believe that our matching strategy really achieves a quasi-experimental, quasi-randomized assignment of kids in schools to treatment versus non-treatment status. Assuming we did that, moving forward. So again, we're using the difference in difference technique for the high schools that work in the redesigns. We estimate a 2-level logistic regression model of students in schools by cohorts. So in that second level, we have indicator variables for all of the schools. The idea there being, so I think that's the point that I believe Bloom makes. It might be Snipes. I think it's Bloom. Makes that if your level 2 units aren't really representative of the full population from which they're drawn, then the idea of just relying on random effects at that level is a misspecification. So that's why we've added these indicator variables at this level. Why do we think that? There were a bunch of schools that implemented the high schools that work model in 2000, but we have no pre-data. We don't have enough pre-data on them to bring in. There's another group of schools, like 18, there's another big group of schools that implemented that model in 2008. We don't have post data on them, so we had to get rid of that. So we figured, okay, well, we already know. I'm not so sure that the timing of when a school implemented this model isn't a random decision. So that's why we were safe and put those indicator variables in. We estimate this model separately for grade, subject, progression, measure, triplet. So grades are 9 in math, 9, 10, 11, science, 10, 11, 12. Subjects, math and science. And progression measure is that course taking or the persistence measure. So our difference in difference estimator is coming in at our level 2 model for the intercept. We have a unique difference in difference estimator for each of the school groups. By school group, I mean reform by implementation year. So the high schools that work, we've got a group that came in 2000, 2002, 2004, 2006, and then we've got 2 years of implementation of the redesigned schools. Why am I doing that complication? Well, it's because we have different amount of pre and post data depending on when they implemented the model. Because again, my observation period is fixed. It's from 1997 to 2009. So if you implement it in 2000, I've got 3 years of pre-data. If you implement it, and I've got, what, 8 years, 9 years of post, 10 years of post data. Whereas if you come in 2007, that numbers are reversed. So, so therefore, we're estimating unique difference in difference estimators for each of these reform by implementation years. We're doing it all in one model, one analytical model.
Yeah, why is that? I mean, you've already told us you would use caution in comparing the different reforms with each other, so you could do a separate analysis for each reform relative to non-reform schools.
And I'm doing that all in one model. So because I've got, so if you you could go in and you could constrain all of the coefficients for, so you wanted to pull out the results for the 2002 implementers of the high schools that work. You could go in and constrain all of the other variables that don't pertain to them to 0, and you would have the school indicator variables for all of those reformers plus their match, and then everything else below you would have unique things for that group. So why are we doing it all in one model versus separate? Well, we already have a bunch of outcomes and a bunch of levels. Multiplying that by 6, my RAs would probably kill me. Second, I think I'm getting some efficiency gains by doing it all at once. So that's my difference in difference estimator. Also, remember I told you about the full treatment versus the partial treatment, and the effects that I'm going to be getting to quickly are comparing the full treatment cohorts to the no treatment cohort. And so we do that by, in the difference in difference estimator, you have an indicator for pre and post period, reform, not reform, and then this reform by period indicator. So we take that interaction and split it between post and full treatment, post and partial treatment. And we're doing log, the logit predict log odds. What the heck is that? That's meaningless. So we convert everything to probabilities, which means any kind of inference you want to draw, you can't use the standard error around the interaction term. So we got to do delta method, a bunch of calculus and matrix algebra. That was fun. Whoops, that was not what I wanted. So I was talking to Kristen yesterday about this project. Moaning, I guess, might be the better word. It's one of those things where you come in and you think, okay, I know the difference in difference estimate. I've done this with, with a continuous outcome. So I'll just apply all my knowledge from that to the nonlinear outcome. And then as you go through, you keep finding, oh, nope, can't do that. Oh, nope, can't do that. So this was one of those moments. So the survival analysis, again, 2-level hazard model. We have separate estimates, separate impact estimates for each of the years that the schools were reforming and our treatment effect. Okay, so quickly, the propensity score, there's a paper that Kristen has if you want it. There's a kind of nasty technical appendix that goes through this. But we're using propensity score weights to correct for both student censoring. We're following students over time. There'll be non-random disappearances from our sample. We want to correct for that. The results I'm going to show you are using the efficacy subsample. So there's non-random movements, mobility away from the initial high school. We want to correct for that. And then this within site school selection at the redesigned schools. Okay, so this is showing the effect of the high schools that work model on the math outcomes. So there's 4 panels here by the year that the schools were implemented. Again, this is math, so you have 9th grade, 10th grade, and 11th grade effects. The dark bars are the persistence measure. Again, that also requires them to demonstrate mastery in the subject. Course taking, they just got to take the course. So what this is showing you, the top part of this, of all of these, that's the treatment effect. If it's green, it's a positive effect. If it's red, it's a negative effect. They're all hatched. None of this is significant. But what this shows you, so okay, let's take an example. So this is a 2000, well, let's go with the, yes, 2000 group. There's no 11th grade indicator here because there was no pre-data. If you go back to that thing, you can, that is clear. So in 9th grade, the students at the schools that are matched to these high schools that works, the model predicts that, what, about 67% of them will end the 9th grade on track in terms of persistence. So they've taken at least one class and they've demonstrated mastery in it. At the students who are at the high schools that work, it's what, 76, 75%? Patterns here. You can see that the course taking numbers are always higher than the persistence, because again, the persistence is a little bit more rigorous. And that you can see that there's over time, the percent of students on track drops. So for instance, let's look at 2000, the persistence at 9th grade, it's what, 67, 10th grade, it's 45, and at 11th grade, there are about 31% of the students who are on track. So what do I draw from this? Okay, the models, I mean, it's a total mixed bag. There's actually only one school here. So this one reform school is doing better in all the outcomes, at all the grade levels, than the students at the 3 schools that's matched to. Yet the 8 schools down here, they're making some positive improvements at 9th grade, but by 10th grade, their students are doing worse than the comparison students. So the redesigned schools effect on math. These 2 panels are for the large schools. So these are the students who choose to remain at the large school at these sites. The 2006 group of implementers, 2007 group of implementers. Over here, these are the small schools, 2006 implementers, 2007 implementers. First thing, while again, none of these effects are significant, which could be because the model has got so much going on in it, could be because I've done something wrong with my differential calculus and matrix algebra, but I mean, because some of these are quite big. The small schools, the size of their effects are larger than the large schools. What do I mean by larger? So originally, one of the earlier graphs of this just showed these tips. But the thing is, a 5 percentage point increase could mean moving from, it means different, I think it means different it means substantively different things if that's moving from 5% to 10% versus 90 to 95%. So what this is showing you is how close to 100% of students on track that additional reform effect is moving the students. There's more, the smaller schools are doing better at getting students towards being 100% on track than the large schools.
Wait, but you're saying all of those effects are insignificant.
Right.
Yes.
So it's all 0. There's no difference between any of them. They're all 0.
So, okay, so yes. If you put that, so if you assume, yes.
Before this talk, we were friends. I hope.
Yeah, I'm done with you.
Yeah.
Again, I need to. These standard errors are quite large, and I've never had to do all of this programming before, so I've got to go back and make sure I've done all that right. But if I've done that right, I'm statistically speaking, these are not significant, and so yes, I can't say with confidence that that's different from 0. Some of them are substantively large. So none of these get to 10%.
Are they at 11%?
A couple of them are. That's why. So I'm not. That's one thing that I've got to go back and look at all those programs and make sure that all of that was done correctly. I'm confident in the effect estimates. Not because of that. I will never use HLM ever again. because you minute me program, so I'll keep that. And this is one of the reasons, is all this sort of post-estimation stuff. If you're not doing a simple model, you've got to jump through a ton of hoops. I might not have gotten through them right. But even if I have, I have a hard time saying that this is all noise.
You would expect at least a handful of those to be, just due to type 1 error, you would expect some of them to be significant.
So.
You have another question here.
Oh, sorry. Sorry.
Away from the statistics, when you talk about 2 or 3 percentage points, how many individual students would?
Right.
It's like, it's 1 percentage point, 1,000 just a student, or is it 10,000 according to the population of your state? I don't know how many students are you really, is it showing that it's an impact?
Great question. So it's not a small number. It's going to be, 1% is probably going to be 100 kids more, in terms of our sample. I don't have the paper with me, but the sample would be in the back of that. That would put, if we're getting 3% more students, how many within this sample are we getting? But the redesigned schools are the largest group of each school. The average size of that school is the largest of the 3, and then there's a fair number of them in each of these groups of performing years. So there's 6 here and 7 here, and there are at least each cohort of kids is going to be several hundred kids. But that's a good point. I'll in the next draft of this, convert some of that stuff to actually how many kids to beef up the sort of if you are willing to sort of put aside the statistical stuff to say, okay, substantively, what does this suggest?
Right, because for those of us who actually recruit, where we're looking for the top 10% of students who graduate from high school, and this gives us good information. We're not looking for the other 90%. So what's those schools that have that model, if it's increasing the performance of those in that top 10%, if that's significant.
That's a good point. Okay, look, so in 5 minutes, can you wrap this up?
So here are early college high schools. The solid bars, the solid tips are significant effects. So we're getting a lot more of movement here with our early college high schools. Again, this is from math. Science, generally these models all tend to have, the effect estimates tend to be negative. Here more for the early college high schools. So let me quickly do the subgroup. So here we haven't yet done the significance, the estimation of the standard errors around these treatment effects. So while these are all solid tips, that doesn't mean that they're significant. We haven't yet assessed that. So what this is showing you, so we have been able to run those student subgroup models for the early college high school. So this is showing you the effects by race for mathematics. You can see that in course taking, the early college high school is doing a pretty good job of closing course taking gaps between the races. So going from left to right, you've got black, Hispanic, other race, and then white. So where they're doing a good job of closing any pre-existing gaps, say that are over here. Potentially, these are pretty flat, but they're moving everybody quite the way towards 100% being on track. Yet, in terms of when we also look at how they're doing on the test, they're doing a decent job at 9th grade. Yet, when we move out in the pipeline, some of those differences still persist or even become more pronounced here. Again, we haven't done any significance testing here with these effects.
What tends to be the ethnicity of the early college kids? the breakdown?
Uh,
Are they disproportionately white?
no.
Okay.
They're not.
They're targeting
Yes.
specific.
It differs by school, by the individual school, but as a population, there's a healthy mix among the races. But between blacks and whites, then Hispanics are about 5-7%, and other races another about 5% or so. But these aren't the balance between the white and black isn't totally skewed.
But it is with Hispanics.
Yes, yes, yeah, and that flows with the overall student population.
Yeah, yeah.
So with the early college, high school, did the matching within district?
Yes.
And so you're looking at kids who selected into schools that are similar to those that
Did not.
right? Who have similar test scores.
Yes, so have similar test scores, similar parental education, and similar test scores to the extent that we have it. Similar test scores, similar whether or not they took Algebra 1 in the 8th grade, their LEP status, their free and reduced price lunch. Those things are on the teacher's judgment of.
What's the availability of a slot in one of those college, high school?
Well, see, Rodney, Julie Edmonds, who's working with him on this, is doing this separate study that he mentioned for the lotteries for the one because it is absolutely a concern, the selection.
Because then I'm worried that if you do the matching that way, it can exacerbate.
Yeah.
So I was talking to someone else, and they were thinking that a better matching strategy would be to match these students who select in to students in districts where there is no option. So, but the challenge there is I think your choice is driven by where you think the unmeasured the selection is coming in where the unmeasured stuff.
Really talented and the one that really wants to go to college.
Yeah.
Right. In which case you're introducing you're keying in on the population where motivation is really relevant, and then you're really worrying about are you picking up. Because then I'm not convinced that it's a coin flip that determines whether or not, once you condition on the propensity score, whether or not you go to one of these GCHS schools, it's really unless you can tell a story where there's some sort of restraint or special school. Yeah.
Whereas at least in the other district that doesn't have it, it's a coin flip. But you're worse than a coin flip here.
Yeah, when I was saying the same, that here we clearly know there's self-selection going on. Students are selecting as opposed to, whereas if you take another district, then you may reduce some of that.
Right.
Yeah. But you said that there's an oversupply of people applying to this, so you actually were in one group.
In some of these schools, there is
quasi-random.
Right. I think people are more willing to believe that districts are more random than students are. That is essentially what you'll have to depend on if you match at the district level.
So you would have done the matching to students in non-ECHS districts?
It'd been easier.
Well, it all depends on how you want to justify the unmeasured stuff. Yeah. So again, when we look at different effects by parental education, we see that the course taking differences are reduced, yet not so much with the persistence estimators or persistence outcomes. And I got one more, and then I'll be done. And same thing. So this is breaking the 8th grade test scores into quintiles, and this is really pronounced in terms of the performance. That the schools are getting the kids to take the classes, yet they're not passing them. There's more something that. Yeah, there's something that has to happen. So some more attention needs to be given to the type of instruction. So then finally, as we move forward, again, I'll react to some of the comments I've received here today, bringing in the last year of data, double checking all of the standard error calculations, and then digging more into this student subgroup analysis. And then, of course, we've got the other two components to this study, which is looking at the results of the survey and then doing these site visits.
Okay, so Luke's flight doesn't leave for another few hours, so if you have questions and you would like to talk to him, please feel free to do so after the talk. Our next seminar will be on October 1st in this room, and it'll be Kalena Cortez from Syracuse. She's also with the National Bureau of Economic Research. She's coming to talk about ranking, this is a Gitchy title, I gotta read it. Ranking up by moving out, the effect of the Texas Top 10% Plan on property values. So what she's trying to get at is whether kids are moving, families are moving to get their kids into a school where they're more likely to be able to get into the top 10%. I think it's a really hot topic that's been understudied, and she's a very, very bright young scholar, so I encourage you to make time to provide for that. So as I mentioned before, the schedule of the speakers has pretty well been set, and it's on our events page in the website. And if you are not on our e-communications list, like you didn't get the invite for today, there's a sign-up sheet outside. Please add your name, and we'll be happy to add you to the distribution list. So on the events page, we'll also have these slides and the paper that some of you may have gotten posted, along with the video, if you'd like to revisit and think more about some of this stuff. So please visit our events page early and often. And thank you again so much for coming today. Have a good long weekend.